All right, today we are going to look at lesson 6. So looking at our exponent rules to get started, remember that if we have, for example, if we have 3 squared, that means 3 times 3, which is 9. 3 cubed is 3 times 3 times 3, which is 27. And if we keep working in this direction, it's like we're multiplying by 3 every time. Whereas if we go in the other direction, we're going to be dividing by 3 every time. So then divide by 3, 3 to the first would be 9 divided by 3, which would just give us 3. And then if we did 3 to the 0, 3 divided by 3 gives us 1. Okay. And then our other piece that we want to remember from what we did before was if I have 3 squared times 3 to the third, 3 squared means I have 2 3s. 3 cubed means I have 3 3s. So in total, we have 3 squared, or 3 to the second plus 3, which is 3 to the fifth. So we can add those exponents to simplify. So for this first one, if we have 2 to the fourth and then 2 to the 0, 2 to the 4 plus 0 just stays 2 to the fourth. That's not going to change our exponent. Our next one, we have 2 to the fourth, and then our other exponent is a negative 1. So we have 2 to the fourth minus 1, which gives us 2 to the third. Then we have 2 to the fourth minus 3, which is just 2 to the 1. And then 2 to the fourth minus 4 is just 2 to the 0, and anything to the 0 power is 1. So just a review of simplifying our exponents there. So example 1, we have a marine biologist estimates that a structure of coral has a volume of 1,200 cubic centimeters and that its volume doubles each year. Write an equation in the form y equals a times b to the t, representing the relationship where t is the time in years since the coral was first measured and y is the volume of coral in cubic centimeters. So the two things that we need to write our equation is a and b. Remember that a is our initial value and b is our growth factor or decay factor. So we have those two given to us already in the problem. 1,200 is our initial value. And then we have doubles each year. So that doubling is our factor. So that means our factor is going to be 2. So our equation would be y equals 1,200 times 2 to the t. Okay. So now we want to find the volume of the coral when t is 5, 1, 0, -1, and 2. So we can just use our calculators for this. So if we're on our calculator, we can take 1,200 times 2 to the -2. We're going to put that in as our exponent, and we get 300. So that's what's going to go in my table here. Okay, and I want you guys to pause the video and complete the rest of the table. So we should have gotten 600, 1,200, 2,400, and then our years jump all the way up to 5. So that's going to be 38,400. Okay. Now remember when we're talking about our value of t, all of these t values here, t is the time in years since the coral was measured, right? So for example, if we were talking about 5, that would be 5 years since the coral was measured, right? We're talking about time in relation to the coral first being measured. So for number 3, if I want to know what does it mean when t is -2, 2 is still an input, so it's still talking about years and time, but we would say 2 years, because it's negative, it would be before the coral was first measured. First, oops, there we go. All right, so then number 4, in a certain year, the volume of the coral is 37.5 cubic centimeters. Which year is this? So if we're talking 37.5 centimeters, if we're looking at our table, oops, if we look at our table, if we're moving in this direction, our numbers are getting larger, right? If we're looking for 37.5, we need to be looking at years before -2. So we need smaller numbers because that's when my coral was smaller, right? It starts small and then gets larger as time goes on. So I want you guys to try to plug in t equals -3, t equals -4, and t equals -5. Try those and see which of those inputs gives you the output of 37.5. So that's going to be when t equals -5. If we have 1200 times 2 to the -5, that would give us the 37.5 centimeters cubed. Okay, and again, because that's the negative time, it's 5 years before it was initially measured. Okay, if we go to our next page, we have a person took some medicine but does not remember how much. Concerned that she took too much, she has a blood test every hour for several hours. So some important things we have here, time t is measured in hours since the first blood test, and amount of medicine in her body, that is m, is measured in milligrams. Okay, so we need to find a couple of things. We need to find our growth factor, or b, in the equation. And then we need to find A, which is our initial value as well. So we can get those from our table. So remember that initial value A, that's always when t equals 0. So we can look at our table. When t is 0, there's 100 milligrams. So A, our initial value is 100. Then to find our B value, or our growth factor, we can divide what do I have after 1 hour, which is 50, divided by what did I start with is 100. And that's going to give me 1/2. So my growth factor is 1/2. So if we want to write an equation in this form, we have m equals 100 times 1/2 to the t. Okay. And then I'd like you guys to complete the rest of the table and use your equation to find when t is -1 and -3. So those are going to be your inputs over here. Okay, so go ahead and pause the video, try to find those, and then continue playing to check your work. Okay, so when t is -1, that's 200. And then when t is -3, that is 800. Okay. Now, number 2 is asking what do t equals 0 and t equal -3 mean in context. So I don't need to find the value. I want to tell me what do they tell me? Okay. So when t equals 0, remember we're talking about time in hours since her first blood test. So if t is 0, this would be the time when she took the first blood test. Okay, so our input is time. It is in hours, but we need to talk about how are we describing the hours. It's in relation to that first blood test. So if t equals -3, that would be 3 hours because that's how we're measuring it in hours. But it would be 3 hours before, because it's negative, she took the first blood test. Okay. And then, for example, if we were talking about like the 2 in the table, since that's positive, it would be 2 hours after she took the first blood test. So we want to talk about our time in terms of before whatever we're measuring versus after if it's positive. Okay. Number 3, the medicine was taken when when t is -5. Assuming the person did not have any medication in her body beforehand, how much medicine did the patient take? So t is our input, and I want to know about -5. So we can just take that equation, 100 times 1/2, and plug in -5 for that input. And we can type that into our calculator. 100 times 1/2 to the -5. That's our input as the exponent. And that gives us 3,200. And that is milligrams. Okay. Now for number 4, we're going to go ahead and plot the points. Just the ones from the table is fine. So our first point we had was when time was -3 and we had 800 milligrams. So we're going to go to -3 and 800, and that's where we're going to put our first dot. Then we have -1 and 200. So that's going to be right here. 0, we're at 100. Then we have 1 hour, we're at 50. And then 2 hours, we're at 25. So we can see our points are decreasing across that graph. We can connect those like that. And there's our graph. And then we don't have to worry about B here, but we do want to look at A. So based on the graph, when do you think the patient will have 500 milligrams of medicine remaining in the body? So the medicine is our Y value on the Y-axis. So we're looking at 500, which is between 600 and 400. So we can find that value, go over to my graph. That would be about right there. Look down at our time, and that's right about in between 2 and 3. So it would be 2.5 hours. Because they're negative, it's going to be before the first blood test. Okay. So make sure to write down any questions if you have them. Get your homework done, and then let me know if you need help with anything. Okay.